Okay, so you should have this notes sheet in front of you, 8.3, Solving Rational Equations, Day 1. So we're going to spend 2 days over this, but today's the first day. We're going to go ahead and get started. Like I said, you have an exit ticket over this. I plan to go through this with you. You'll get classwork, and we'll do a couple practice problems together, and then you'll do your exit ticket, which you can work with a partner silently. That means not talking. And also I'll let you use your notes since I am not here. But hopefully the video will do. So stay off your phones and listen up. Okay, so first thing we're going to look at is the equation 4 over 3 minus x equal to 1 over x plus 2. Does this represent an example of a proportion? Well, yes, it does, because a proportion is a fraction equal to another fraction. So you can solve proportions by cross multiplying. So that's exactly what we're going to do. When I teach this in Algebra 1, I teach them to kind of draw like a little butterfly, and they just cross multiply these two expressions, but we're going to have to distribute. So on the first side, I'm going to have 4 times x plus 2, and then on the other side, I'm going to have 1 times 3 minus x, and I set them equal to each other, and I'm just going to cross multiply here. So then I'm going to go ahead and solve it. So I distribute in 4x plus 8 equals 3 minus x. Solve for x. 5x equals negative 5. Just moved over the minus x, moved over the 8, and so I get that x equals negative 1. So what was my solution? X equals negative 1. Now this is also a rational function, so we have to think about what values, what restrictions we might have. So to do that, we look at the denominators, and we say that this denominator cannot equal 0. Same thing with this denominator. It cannot equal 0. So what values of x will that happen? Well, this is going to be 3 cannot equal x. This one's going to be x cannot equal negative 2. Is negative 1 one of those numbers? No. So my restrictions would be x can't equal 3 and x can't equal negative 2. So is x equals negative 1 valid? Yes, because it's not one of those restricted numbers. It is valid. Okay, so when you're solving these, you're going to need to think about what your restricted values are first. And then once you get your solution, if one of those happens to be a restricted value, you won't use it as your solution. You'll just throw it away. But if it isn't a restricted value, then it is a solution and you're good to go. So the next part says proportions are familiar to us and they're relatively simple to solve, as I just did my cross multiplication. Using what we've learned about simplifying rationals and rewriting a rational equation into proportion form will allow us to use the above technique, which was just cross multiplying, to solve rational equations. Okay, but like I said, in order to use cross multiplication, I have to have a proportion, which is one fraction equal to another fraction. So if I look at number 1, do I have one fraction equal to another fraction? No. But using what I did last time to make this into one fraction, I can just find a common denominator and go ahead and turn this into one fraction equal to another fraction. So first thing I'm going to do is I'm going to have to give this a common denominator. So my least common denominator would be x. So that means that in order to get this also over x, I need to multiply 7 by x. So I end up having 4 plus 7x, because that's 7 times x, all of it is over x, is equal to 2 over 3x. Now I've got a proportion and I can cross multiply. So I have 3x times 4 plus 7x equal to 2x. That's going to give me 12x plus 21x squared equals 2x. Move over the 2x, and I'm going to put the 21x squared first because that's the order that I like to write this in, and 12x minus 2x is 10x equal to 0. And then to solve for x, I can go ahead and factor out a GCF of x, and that leaves me with 21x plus 10 equals 0. So from here, I know that both of these need to be equal to 0, so I get x equals 0, and 21x plus 10 equals 0. which gives me 21x equals negative 10, which gives me that x equals negative 10 over 21. Now, think of restricted values. Before we can give our answer, this tells me I have two solutions, but are they valid? Well, x cannot be 0. 3x cannot be 0, which just gives me x can't be 0 because 0 divided by anything is 0. So this solution is valid. This solution is not. So I go ahead and throw that out. So that would be an example when my restrictions actually end up restricting one of the answers that I get when I go through this process. So what we did was we started with not a proportion, we turned it into a proportion, we cross multiplied and solved for x. So if you go ahead and flip over, there's another way that we can do this that is a little bit easier algebraically. We're going to solve the same problem. 4 over x plus 7 is equal to 2 over 3x. But we need to look at all three denominators and determine the least common denominator. So my least common denominator is going to be 3x. So now if I want to solve it, I want to turn in this problem to where both sides have a common denominator of 3x, okay? So right now, this fraction, I'll go ahead and rewrite it. 4 over x plus 7 is equal to 2 over 3x. This side already has my common denominator of 3x, so I'm good. So what would I need to multiply 4 by to get a denominator of 3x? By a 3. 7 to get a denominator of 3x, I would need to multiply, because this is 7 over 1, by 3x. And then I'm going to go ahead and multiply through and see what I get. Well, this is going to give me 12 over 3x plus 21x over 3x is equal to 2 over 3x. I can go ahead and write that, write this side as one fraction, so 12 plus 21x over 3x equals 2 over 3x. So now I have a proportion. Instead of cross multiplying though, what happens is since I have 3x in the denominator on both of them. So let's say that I wanted to move this. Since this is being divided, to move it to the other side, I would multiply both sides by 3x. On this side, they would cancel out. But on this side, since they're the same, they also cancel out. So what I end up having is 12 plus 21x is equal to 2 because my denominators canceled out. And then I end up solving for x. So I get 21x equals negative 10 and x equals negative 10 over 21x, which is what I got on the other side. So just a different way of going about it. When we get really good at this, we're not going to have to do all these steps every single time, but I wanted you to see what would happen is once you have both sides over the same denominator, essentially they'll just cancel out because of this property here, and then we can just focus on the numerators. So once we get a common denominator on both sides, we focus on the numerators and then we solve. Okay, so I'm going to go ahead and stop the video before I run out of storage again, and then I'll pick back up and we'll work 3 and 4.